So we'll see introduction regarding the electronics subject. So some terminology we have to understand. So first of all, what is electronics? We'll see, and then we'll see what is electronic device. So in our subject, we are going to see some electronic devices like PN junction diode, bipolar junction transistor, MOSFET, like this we are going to see. And the applications also we are going to see, like half wave rectifier, full wave rectifier, bridge rectifier. These are the applications of the electronic devices. Okay, those things we are going to see. And after understanding what is electronic device, we are going to see electronic circuit. Okay, first we will understand the terminology related to electronics, like some terms I have given, like electronics and electronic device and electronic circuit. Okay, so electronics is nothing but it is the study of motion of electrons. Simply we can able to tell electronics is the study of the motion of the electrons, but those electrons must be available under the influence of electric field and magnetic field. Okay, so again I am repeating, electronics is the study of motion of electrons under the influence of electric field and magnetic field. Electric field is generally represented with E bar and magnetic field is represented with H bar. Okay, so these electrons must be available in electric field and magnetic field, or electric field or magnetic field. Then based on the motion of the electrons, whatever the study we are going to do, that is called electronics. Okay, then what is electronic device? So what is electronic device means, you take any device like a PN junction diode and transistor, whatever it may be. So when can we say that particular device is the electronic device is nothing but the operation of that particular electronic device. The operation of that electronic device is controlled by electrons flow. Everything is related to electrons only. Okay, so based on the electrons flow, how the electrons are moving, based on that one, if the operation is dependent or the operation is controlled by the electrons flow, then we can tell that particular device is the electronic device. Okay, then we will see what is electronic circuit. Electronic circuit is nothing but, for example, if I take one resistor, this is the resistor symbol already you know. So one resistor is there, one capacitor I am taking, here certain supply has been given, V volts, and it is a resistor R, capacitor C. Can we say it is a electronic circuit? No, we cannot say it is electronic circuit, because resistor and capacitor, these are the two elements available in this particular circuit, and these two elements are electrical devices, are electrical elements. So it is called electrical circuit. When can we say one circuit is electronic circuit? Is nothing but the circuit should involve the electronic device such as the diode. It is the diode symbol. So in this particular circuit now, including the electrical element like resistor, here we have the diode also. So diode is the electronic circuit, and the main operation of this particular circuit is based on the diode only. That's why we can able to treat this one like a electronic circuit. Okay, it is the electronic circuit we can able to tell because it is involving the electronic device diode. So what is electronic circuit means? What can we tell? The circuit operation should be dependent on the electronic device, or we can tell at least the circuit should involve at least one electronic device. Electronic device. If at least one electronic device is available in the circuit, then we can tell that circuit is nothing but electronic circuit. Okay, this is the basic terminology we are understanding to start about the electronic subject, like what is electronics, what is electronic device, and what is electronic circuit. Now we'll see some elements. So in our subject, we are going to deal with some elements. Those elements we can able to take two ways. One is active element. Second one is passive. One is active element and second one is passive element. So what is active element? Active element is nothing but from the electrical circuits knowledge, you can able to tell the device or the element which can provide energy to the circuit. Okay, the element which can provide energy to the circuit, the element which can provide energy to the circuit or the element which can energize the circuit or the element which can energize the circuit, that element is said to be active element. Okay. What are the examples for this one? Very well known examples are voltage source and current source. Voltage source and current source we can able to give as the example of the active device. This one you know already from the electrical circuits knowledge or the network theory knowledge, we can tell what is active element is nothing but generally voltage source and current source only. And these are the reasons for the energization of the circuit. Okay, in the circuit you may have resistors, inductors, capacitors. So all those passive elements actually RLC are called passive elements. All those passive elements can be energized by the voltage source and current source. That's why voltage source and current source can be treating like this active element. So generally active element is nothing but what can we tell? Voltage source and current source. And generally what are the passive element is nothing but RLC. So voltage source and current source are providing the energy to the circuit which are involving the resistors, inductors and capacitors. So these are dissipating the power which is provided by the voltage source and current source. Okay. So these are for energizing purpose, these are for dissipating purpose. But it is not enough to stop the definition of this particular active element here itself. Okay. So one of the definitions for the active element is the element which can energize the circuit. And now we are going to see the new thing. Active element can be used as switch also, or we can tell the element which can be used as switch is nothing but active element. So this is another definition we can able to take for the active element. It is a new one for you. Okay. So the element which can be using as a switch. What is the example for this one? Again diode only I am taking. So this is the actually PN junction diode. We are going to see this one in our syllabus. So here one triangle symbol is there and beside that one vertical line is there. And two terminals will be available in case of the PN junction diode. One is called P, second one is called N. And this is a element which can able to use like a switch, on switch and off switch by providing the external biasing. All those things we are going to see later. So anyhow at this moment, the second definition for the active element I have given like the element which can be using as a switch. Okay, example is PN junction diode. PN junction diode is nothing but switch. Okay, the application of the PN junction diode is switch. So because it can be using as a switch, it can be treating like a active element only. So remember this point, PN junction diode is active element, not passive element. Okay. And another definition also I am giving, that is nothing but the element which can be used as amplifier. Which can be used as amplifier. So not only as a switch, okay, but also we can able to take amplifier. So the element which can be using as the amplifier can be treating like the active element only. So in our syllabus you can able to observe the BJT, bipolar junction transistor. Bipolar junction transistor can be using as the amplifier. Okay, what is amplifier means? The input to the amplifier can be the weak signal and the output of the amplifier should be the strong signal without changing the shape of the signal. Okay, so in our syllabus we have this amplifier also. Okay, So BZT can be using as the amplifier for strengthening the weak input signal, so that we can able to tell BZT is the active element. So now third definition is also over. So what are the three definitions we have given for the active element is nothing but active element is for energizing the circuit. Active element can be using as a switch. Active element can be using as the amplifier. Now we will see the passive elements. Already I told that resistor, inductor, capacitor can be using as passive elements, and these are not for the generation of the energy. These are for just dissipating the energy or dissipating the power. And one more thing is resistor is always dissipating only, always dissipation. But in case of inductor and capacitor, these are for storage of the energy, storage of energy in the form of magnetic field and electric field respectively. That means inductor can able to store the energy in the form of the magnetic field, and capacitor can able to store the energy in the form of electric field. Okay. Even though these are for the storage of the energy, we need to treat these two like a passive elements only, because these are not generating the energy. Okay, because of that reason, we'll treat these three like a passive elements. Okay, so summary I'm giving here: voltage source, current source, these are the active elements because these are for the energizing the circuit. And diode, this is the diode symbol again I'm taking. The PN junction diode is also active element only because it can be using as a switch. And BZT, the BZT symbol now I am giving, it is one of the BZT. Okay, this is actually NPN transistor, NPN bipolar transistor. Okay, you will see all these things later. So this is also the active element only because it can be using as the amplifier. Okay, so all these things are active elements because of different reasons. And resistor, inductor, capacitor, these three are passive elements. Okay. So this is a little bit introduction to the electronics we can able to tell. Now we'll see what is energy. We need to deal with energy. Okay, in our introductory classes, we need to deal with actually energy band diagram. For that, we need some information regarding the energy. So in the electrical circuits or the network theory, network analysis, you may understood that energy can be measured in the units of joules, but it is very large unit. So we need a very small unit because we need to deal with electrons. Okay, very small unit is required. It is actually large unit. It is actually large unit. So what we need to do? We need to define another unit, that is electron volts. It is very important. Electron volt. Electron volt itself is we can able to treat like a another unit for the energy. What is the difference between these two means? It is used for very small quantities. Okay, so we can able to tell it is a small unit of energy. It is the small unit of energy. So whenever you are dealing with semiconductors, you can able to remember that electron volts is the unit of the energy. Okay, in the electrical circuit subject, you can able to treat whenever semiconductors are not involved. At that time, you can able to take the energy unit is the joule. Okay, now onwards we have to remember that joules and electron volts both are units of energy only. Whenever you are dealing with the semiconductors like silicon and germanium, in our subject we are going to deal with electron volts only. Electron volts is the unit of the energy. Okay, then what is the meaning of that one? One electron volt can be related to joules. Okay, so I am saying that it is very small unit. So 1 electron volt should be some multiplication factor of 1 joule. What is that multiplication factor is nothing but 1.6 into 10 power minus 19. This number already we are familiar with. Okay, that is charge of the electron. 1.6 into 10 power minus 19 coulombs is the charge. Okay. So here anyhow, the relationship between 1 electron volt and joule is given by this equation. What is that? 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This equation is giving the information that when you multiply 10 power minus 19 with 1 joule, okay, forget about this 1.6. So when you multiply 1 joule with 10 power minus 19, you will get very small value. That value is your electron volt. So we can able to easily tell that electron volt is very much smaller compared to 1 joule. That is what I have told previously. Electron volt is a smaller unit compared to joule. Okay. And in terms of the electron volts only, we are going to deal with our energies of the electrons in our subject. Okay. And what is the meaning of this one? Generally, energy work done both are measured in joules only in our electrical circuit subject. Okay. So energy is related to work done. That means when you move one electron from one place to another place, then it is getting certain kinetic energy. Because of the getting the kinetic energy only, the charge is moving. Okay. So whatever the amount of kinetic energy is gained by the electron by providing certain potential. Okay. Based on that one, this electron volt has been defined. Again, I am telling the kinetic energy gained by the kinetic energy gained by an electron, the kinetic energy gained by an electron by providing 1 volt. You see in the electron volt, electron is there, volt is there. So if you provide 1 volt of potential, then the electron is gained certain amount of kinetic energy. That kinetic energy, it is the energy. So that itself is your 1 electron volt. Okay. Or we can able to tell because it is getting the kinetic energy, it is losing the potential energy. So the definition can be given in a different manner also. The potential energy lost by an electron when you provide 1 volt potential. Okay, both are same. Losing the potential energy, getting the kinetic energy, both are same. In this manner, we have defined this electron volt. Okay.